Welcome back to Fun with Crypto. Brent Bilger with you, a Director of Technology at Verizon, but these are my words, not Verizon's. In Part 3, let's learn about AES, the Advanced Encryption Standard, and its modes of operation. AES is a symmetric key block cipher that uses the same key to encrypt plain text into ciphertext as it uses to decrypt the ciphertext into plaintext by reversing the order of the operation. The algorithm takes a block of 128 bits of plaintext and transforms it into a block of 128 bits of ciphertext. The cipher uses a key and a number of rounds to generate the ciphertext, where a round is a number of steps in the algorithm that are repeated a number of times. AES is a family of 3 ciphers. The 2 common ones are AES 128 and AES 256. AES 128 uses a 128-bit key and 10 rounds. AES 256 uses a 256-bit key and 14 rounds. Both of these are believed to be cryptographically secure, meaning there is no efficient way to break the code when generated properly. There's also AES 192, which is rarely used. Note that all 3 encrypt a 128-bit block of plaintext. It's just the size of the key and the number of rounds that differ. But if AES can only encrypt 128 bits, how does one encrypt something larger? This is where the modes of operation come in. And of course, one could just encrypt the various blocks and string them all together. This is called Electronic Codebook mode. However, identical blocks of plaintext show up as identical blocks of ciphertext, which can significantly leak information about the underlying plaintext. If you look up Electronic Codebook in Wikipedia, there's an impressive set of pictures that shows just how much can be leaked. This is an insecure mode of operation and should never be used. There are a number of other algorithms that could be used, but there are 2 in particular that are used. The first is Cipher Block Chaining mode. In this mode, each block of plaintext is XORed with the preceding block of ciphertext. Then, an initialization vector is XORed to the initial block. The other common mode is Galois counter mode, and it is a very interesting mode because instead of encrypting the plaintext, it encrypts a counter. Previously with Cipher Block Chaining, we saw how AES encrypted a 128 block of plaintext with its secret key. But with Galois counter mode, AES encrypts a 128-bit counter with its secret key. Now typically, the counter consists of a 96-bit initialization vector and a 32-bit counter. The counter increments by 1 for each AES block. The result of the AES encryption of the counter is a 128-bit stream of bits, which are then XORed with the 128 bits of plaintext to generate 128 bits of ciphertext. Note that the plaintext is encrypted by the cipher stream, not directly by the AES cipher. Then, the counter is incremented. That counter value is AES encrypted with the AES secret key to a different stream of bits, which are then XORed with the next 128 bits of plaintext into ciphertext. And on it goes. In the next video, we'll take a more thorough look at the Galois counter mode and why it's become so popular. That's pretty much all you need to know about AES encryption, and so this video will stop here. In a future video, we will dig deep into the AES algorithm, but for those of us looking to apply cryptography instead of invent it, we can treat AES in the Galois counter mode as a black box. Select a truly random key and a plain text message, use the algorithm to encrypt the message, send the encrypted message over an untrusted network, or store the message on disk, then reverse the algorithm to get back the plain text. Join us next time to learn a little more about the Galois counter mode.